This is the second video in the dimensional analysis lecture. So we have previously learned how to use this idea of conversion factors to convert between units. So we did things like miles to kilometers and kilometers to inches and things like that. Okay, so this is a little bit of more complicated discussion, but still the same idea of using dimensional analysis. Okay, so in this problem, we're given 4.5 meters per second is how you would read that, and we want to know how many miles per hour that is. Okay, so meters per second and miles per hour are both speeds because they're distances over a time, and so we could investigate if these speed conversion factors were on our sheet, but they're actually not, and I've picked that for a reason, because I want to show you how to approach this problem by breaking it down kind of individually. So here's what we're going to do. We're going to write my 4.5 meters, and then I'm going to do something a little bit different, draw my crossbar. Okay, but see, I've left out the second, and so this is because it's very important that you write this in this way. So what does 4.5 meters per second mean? Well, it actually means 4.5 meters per every 1 second. Okay, and so this line is my fraction bar. So 4.5 meters per every 1 second is what this looks like. So this is different. We've never had anything hanging out in that space in the denominator before on underneath the number we were given, because we were only ever given 1 unit. But meters per second is actually 2 units, and it in and of itself is a fraction. So I have 4.5 meters per every 1 second. All right, so in this case, I'm going to treat this like 2 separate problems. And so I'm going to treat it like I need to convert meters. Oh my goodness. I had an extra there. So like I need to convert meters to miles. And then like I need to convert seconds to hours. Okay, because if I can successfully convert the meters to miles and the seconds to hours, then I'll have miles per hour, which is what I want. So I'm just going to pick one to start with. It doesn't matter which one you pick. So let's start with the meters and the miles. So I'm just kind of going to ignore the fact that this second is there. Okay, it's not going to go away. I'm just going to ignore it. So I want to change my meters into miles. So my meters can cancel, and I would be left with miles. Okay, remember, I'm just ignoring the second. So I go to my conversion sheet, and I'm looking for the meter and the mile. And let's see, I bet it's not on here because it's not, is it? No, but the mile to the kilometer is. So this is going to be one of those odd ones where we're going to go from meter to kilometer to miles. So I kind of lied to you. And this is all about making that path. Okay, so I'm first going to go from meter to kilometer. And so I'm going to look at my sheet, and I learned that 1 kilometer has 1,000 meters. And so if I stopped right here, my unit for this problem would be in kilometers per second. Okay, so that's not what I want. So of course I'm going to keep going. Now I can take my kilometers and turn them into miles by looking at my paper. And I learn, let's see, that 1 kilometer is 0.62, we've done this one before, 137 miles. Okay, so again, my meters are gone, my kilometers are gone, and if I were to stop right here, my answer would be in miles per second. So I'm close. I have now successfully completed this part of the conversion, but I need to do my seconds to hours. So this is where it's a little bit different, because watch what happens. I'm now concerned about getting rid of my seconds, and seconds are in the denominator. So now seconds has to go in the numerator so that it cancels. Okay, now you might not know how many seconds are in an hour. That's okay, but we do know the relationship between seconds and minutes. So again, we're going to do another kind of middle man, so to speak, and go from seconds to minutes. So in 1 minute, there are 60 seconds. And then, I almost ran out of room. My last one, I want to convert minutes into hours. And we know that in 1 hour, there are 60 minutes. Okay. So if you, I forgot to cancel my minutes. There we go. If you look, all my units have canceled except for miles per hour. So other than doing a calculation incorrectly on my calculator, I have to be correct because my units are correct. Okay, but let's talk about that that calculation on your calculator. Again, remember 2 ways to do it. You can multiply all the way across the numerator, multiply all the way across the denominator, and then divide those two numbers. Or you can move from left to right, but you just have to keep track of whether you're multiplying or dividing. Okay, so I'm gonna move from left to right. So I'm gonna take 4.5 and divide it by 1,000. Oops. I'm gonna hit equals. And then everything else is in the numerator. So everything else will be multiplied. So then I'm gonna take that answer that I had, which was 0.0045, and multiply it by 0.62137, multiply that by 60, and multiply that by 60. And I think I just hit a wrong button, so hold on, let me. Okay, so then I get an answer of if we round, 10.1 miles per hour. And that is my final answer. Okay, and that you should achieve that answer whether you multiply across the top and across the bottom and then divide, or if you kind of move from left to right. So that's a slightly more advanced dimensional analysis type of problem because of the double unit involved. Okay, so but again, if you just break it down into each individual section, you should be okay. I want to do one more because I want to show you how sometimes the problems don't look like this at all. So give me just a minute. Let me write this problem down. So the problem says a 1 milliliter volume of seawater contains contains 4.0 times 10 to the negative 12 grams of gold. The total ocean volume, so the volume of the water in all the oceans, is 1.5 times 10 to the 21st liter. That's a lot of water. So this problem wants you to calculate the total grams of gold in the ocean and its worth if gold is $350 per ounce. What? Okay, so this is a problem. This is a complete dimensional analysis problem, but it surely does not look like it. Okay, so I want to show you how we can solve this. So what's the goal? Well, there's actually two goals, and the first goal is the total grams of gold, right? So I want grams of gold. Ooh, I'm going to use its chemistry symbol here, sorry. And I want to know its value, its worth, which means I want to know how much money. Okay, so those are the two things I'm looking for. So let's start with grams of gold. Now, there have to be grams in this problem somewhere because that's what I'm interested in obtaining, okay? And so there it is, it's right here. So obviously I have to work with that. But that's just the amount of gold that's in 1 milliliter of ocean water. So can you see that that's going to be a conversion factor? 1 milliliter of ocean water is equal to 4.0 times 10 to the negative 12 grams of gold. Right, that's a conversion factor. And then I know that the total volume of the whole ocean is this. So that's definitely going to be important. That in all the oceans, I have 1.5 times 10 to the 21st liters. Okay. So there's numerous ways to do this, but let's just start with this number. Okay, so I know that that's the total volume of the oceans. And I'm somehow trying to get grams out of that. But we have this conversion factor that converts milliliters to grams. So I have to use that somewhere. But I can't use it right now because, of course, my volume is in liters. So can you kind of see the path that I need to change those liters to milliliters? And that in 1 liter, there are 1,000 milliliters. Okay, and now I can use this conversion factor and it will let me take my milliliters and turn it into grams because this problem told me that in 1 milliliter of ocean water, there's this many grams, right? Now this conversion factor is not like 12 inches in a foot per se, but it's a conversion factor in this problem, and so I can use it. So if I do this math correctly, I will get my grams of gold. So 1.5 times 10 to the 21st power, right, times 1,000 times 4.0 times 10 to the negative 12. And I'm going to get a very large number. I get something like, let's see, what is that? Oh my gosh, 6 times 10 to the 12th grams of gold. That's a lot of gold. Okay, so I've answered my first question. In all the ocean water combined, there should be 6 times 10 to the 12th grams of gold. That's a lot of gold. The second question, though, was what's its value? Okay, so I'm trying to get money. And they, of course, told me that gold is valued at $350 per ounce. So I need money out of this somehow. And I also know that I have this many grams of gold. And I know it's worth $350 per ounce. So I'm going to need to take my grams and change them to, at the bottom of my page here, sorry. Let's see if I can move this. There we go. And I need to change that to ounces. Okay, so I'm going to go on my, my conversion sheet, and I'm looking for grams to ounces, and there it is, like the third one down tells me that 1 gram is equal to 0.03527 ounces. And then for the first time that we've never done this before, I'm going to use the fact that 1 ounce of gold is equal to $350. Right? We've never used money in the conversion, but we're going to today. Oops, 1 ounce of gold. So look, grams are gone, ounces are gone, and in this case, I'm going to end up with money, which of course is the question. They ask me how much is it worth. So I go to my calculator, I do the math, 6 times 10 to the 12th times 0.03527 times 350, and I get a huge number. Let's see, 7.4 and some change times 10 to the 13. That's a lot of money. That's a lot of dollars, right? So the question, hopefully your question is, how come we aren't doing that, right? How come we aren't harvesting all this gold? That's way beyond a billionaire. And the answer is they've tried. But it's not, it doesn't quite so easily is it able to be recovered from ocean water, and that process takes a very long time and costs a large amount of money. So it would not be a productive business venture to try to collect the gold in ocean water. But so anyway, so that is how you can use dimensional analysis where it doesn't often look like it's a dimensional analysis problem. And questions like these are infamous for appearing on advanced like exams and ACT, SAT kind of stuff. And dimensional analysis will help you with so many things. If you just can remember that the whole goal is to cancel out units and to get the unit that you want in the end. And so dimensional analysis is a pretty cool technique to have in terms of